I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and today I have a reply and the continuation of our video regarding the 29th of February and the potential issues that could come up in software due to this date. Jofla posted a comment to this video asking, could you or someone in the comment share a previous experience when you had a problem with this? That is with the leap year with 29 February. And the first one that popped to my mind was the issue with Windows Azure on February 29th, 2012. I know it's a long time ago, like 12 years ago, but the thing with these bugs, they tend to, because they come every 4 years, we tend to forget that they are possible, so it's likely that you get them back. And so it's very important to understand the issue and how to deal with that. And I'm just going to do this very briefly today. What happened with Azure in February 29th, 2012? I think it was down for like 24 hours or so, which is a big thing for a cloud infrastructure organization. And the reason was that basically on 28th February, some of the certificates that they were using expired, and on 29 February 2012, the system tried to create some new certificates, but by default the valid to date, so the date until when the certificate is valid, was computed to be year +1. So because it was 29 February 2012, it was computed to be 29 February 2013, which is not a correct date, and this made the certificate creation to fail, and this brought down a whole lot of infrastructure. Okay, and this is just one example, and I know you can easily ignore and say, okay, this happened a long time ago, but remember, every 4 years this can happen. And if you want to learn more, search for the leap year problem on Wikipedia. There are basically two categories. Leap year bugs typically fall into two categories based on the amount of impact they may have in real-world usage. Those that lead to error conditions such as exceptions, error return codes, uninitialized variables on endless loops. Those that lead to category 2, those that lead to incorrect data such as off-by-one problems in range queries or aggregation. And then we have a bunch of examples here. And the typical one is if you compute a date by taking the year, adding 1, and this computation happens on 29th of February, basically what we saw with Azure. And this happens more than you might expect. Instead of doing the correct date time calculation, which would be, let's take a date time, add a time span, and so define a time span of 1 year that you add to the date time, and let the date time classes figure out the correct date. And here on in this article, you also have a bunch of links to various problems, including a list of 2020 leap day bugs at the website Code of Math, where you could see a bunch of additional issues that happened in 2020. So if you want to read some more, these are the places where you could go. And let's see if we can find some more information here. So Gmail chat history showed the date of December 31, 1969 for all chats saved on February 29 in 2012. I remember this one. In 2012, TomTom satellite navigation devices malfunctioned due to a leap year bug that first emerged on March 31. Sony's PlayStation 3 incorrectly treated 2010 as a leap year, so the non-existent February 29, 2010 was shown on March 1, 2010 and caused a program error, and so on. In midnight on December 31, 2008, many first-generation Zune 30 models froze. Zune was a music player from Microsoft. Microsoft stated that the problem was caused by the internal clock driver written by Freescale and the way the device handles a leap year. It automatically fixed itself 24 hours later. So basically, on midnight, the MP3 player stopped working and then it started working again 24 hours later. But then there were also other things. In 1996, December 31, two aluminium smelting plants in Tivai Point, New Zealand and Bell Bay, Tasmania, Australia, each of the 660 computers controlling the smelting pole line shut down on midnight since the computers were not programmed to handle the 366th day of the year. Repair costs were estimated at more than 1 million New Zealand dollars. So what can you do about this? Basically check every occurrence of date time in your system, and particularly the computations, because the problem seems to mostly come up when you compute dates using operations that don't use daytime and time span, but instead use things like integers and adding 1 to the year or things like that. And also a more difficult one is when you have an assumption that the year is 365 years, 365 days. So that might be another problem. So what I would advise you to do is to, well, there are two things. One is you can search for datetime in your code bases, but even better it is to write the code such that you can write unit tests where you inject, you send as an input parameter the date 29 February 2024 and see how this happens. But given that we are only a few days since 29 February, this might not work as well right now. But it's well, you do well to remember it for the future. So this is it for now. I hope this helps, and I hope you don't have any issues, first of all. But if you find any, I hope you'll find them in time and fix them, or at least learn something from this video. Thank you kindly for the view, and until next time, remember to think, design, and work smart.